Yeah, you got the first one correct, Cody. Nice job. This one here is correct. Nice parentheses. Well, you need to have the parentheses around the parentheses. So you need parentheses around the whole iron, because this is like iron. The name for it is ferrocyanide, so it would be calcium ferrocyanide. And then this one here, you want to put the parentheses around the S2. That's really good that you got parentheses there. So that would be aluminum sulfate. Now what's this going to be called?
What, first one?
Yeah.
It's not rust.
It is Fe. What's Fe?
Iron.
Iron what?
Trioxide.
Very good. Now today we're going to go into the lab. We're going to basically make a compound. You're going to take fire and you're going to mess with magnesium, making it into an ion. You're going to burn it. And it's going to react with oxygen in the atmosphere. That's where you see this O2. So everybody clear, this is what you're going to make today, magnesium oxide. Now you can test for it. It is magnesium oxide. So we've got our magnesium here. We've got 0.49 grams. Now this is called a balanced equation. You're going to take magnesium and you're going to react it with oxygen and you're going to make magnesium oxide. This is what we're making. So the problem here is you have one magnesium and you have one magnesium. That's good. That's not a problem. This is the problem. You have two oxygens and you have one oxygen here. Now why do we have one oxygen on the magnesium? Anybody know? Why is there only one oxygen on the magnesium?
Because oxygen has a Q- charge and balances it out.
Exactly. It goes back to this right here. So we can't just change things. We have to observe where they want to be balanced. We just make observations. That's how we predict the future. So we have to go over here and we have to double this. So that gives us two oxygens. Does everybody see why I did this? To give me two oxygens. So this is balanced. So we're going back to the same idea of balancing. Balancing. Just building on the balancing. Two oxygens. Now we have two magnesiums, so I have to add another magnesium over here. Does everybody see that? Any question there? Then I draw a line and I add them up. So I have my two magnesiums plus oxygen gives me two magnesium oxide. This is called a balanced equation. We need that to do stoichiometry. We're just introducing it today because when we take this magnesium, what I want to test for today is to see if you... So if you do the math here, you're going to see that the answer is 0.81 grams. In the crucible, we're just going to take a wet paper towel, wipe it out, another paper towel, dry it. Alright, just dry it this way. But we don't want it to put the water on it because the water is really cold. And the cold and the hot cause these things to break real easily. So that's why I don't recommend putting it in water. Wait.
Try and get the fire to go down a little bit.
Can I get that cone?
Wait, is this a wash? Okay, no, just like... So it looks like it's going down.
What? Yeah.
There we go.
Cody's, yeah. Oh, well, okay. And then what? Well, then you want to ask Mr. Steiner? Did you put anything in this
You're going to put the magnesium in there after you measure it out.
Well, they're already measured, so they're just like... Where's the stuff that's going to be burning?
Yeah, I'm getting there. Alright, hold on. Let me get the crucible tongs. Crucible top, like this. Sit around. Put it on the top there. Like that. See how that works? It's pretty simple. Now, to move the crucible, when it's hot, you're going to let it cool. What I do, like if this is sitting on the ring stand, take the top off, and then I grab it like this. Does everybody see this? I grab it like this. So if it's on the ring, like this, right here, I'm just going to grab it, and I'm going to take it to the table and let it cool. Now, some people like to do it this way.
Put it on a paper towel.
Well, you're going to let it cool first. You put it on paper towel, it could catch on fire.
No, you turn the gas on.
I thought you're not supposed to put it on this because it changes temperature.
You could, yeah, it's true. You can, well, you're supposed to let it cool on this for a couple minutes, and then you're going to put your hand over it. When it's not hot to your hand, don't touch it. You should be able to feel the heat on it. Then you can take it off. You can put it on the ring stand like that. But by the time it's touchable, you should be able to put it on the table. That's good. You want it to get really, really hot. It should be glowing red.
Underneath it?
That's perfect.
Okay.
Right. Now give it about, I don't know, 7 or 8 minutes. And then you can take the top off just a tad and it'll let some oxygen in there. Because remember, the magnesium is trying to react with the oxygen. What you're doing right now is getting the temperature up really high so it'll do that.
Do we put the lid on?
So it'll catch on fire.
When you take the lid off, do you turn off the gas?
No, keep the gas on. When you take the lid off, what should you not do, Ryan?
Use your hands.
No. What should you not do, Ryan, when you take the lid off?
Turn the gas on.
Look directly at what? Yeah, the burning magnesium will be very bright. So you don't want to look directly at it because you'll be like, oh, yeah, I'm seeing spots.
Oh yeah,
But you can see how the oxygen's reacting with the magnesium.
Whoa, there's like white smoke coming out, not normal smoke.
Now you don't want the ashes to get out of there because that's going to affect your results. So we're just going to gradually put the cap back on and let it cook a little bit more. And then we'll take the cap off probably maybe 1 or 2 more times. Now make sure that you weigh it with the lid if you started with the lid. Picking up the Crucible. I know you're going to want to think that it's white and it won't hurt you, but 5 minutes after you heat it, it's still hot and it can burn you. So don't think, oh, because some people don't judge time very well. Like the brain games, they said, can you count to 8 seconds and match the stopwatch? Most people couldn't do it. Only the rodeo bull riders can do it because they got to stay on a bull 8 seconds. So up here, we're going to take some magnesium right here. This is magnesium, and we're going to react it with oxygen. So 80% of what you breathe, that is the atmosphere, is oxygen. 80%. Correction, that's not 80%. 80% is nitrogen. About 19% is oxygen. A little over 19% is oxygen. Nitrogen is the most abundant gas in the atmosphere. So we're going to take magnesium, and you're going to react it with some oxygen, right? Now, this is a 2 positive, 2 negative. That's why it's MgO. We've been doing this, balancing compounds, right? Balancing ions to make compounds. Magnesium oxide. So this is the equation, the balanced equation for this. You got some magnesium plus some oxygen, you make magnesium oxide. The problem here is you got 2 oxygens here and you have 1 there. So I got to double this. I'm going to make 2 of these. It's like automobiles. How many automobiles can you make with the parts that you have? Make sense? Bicycles the same way. You got to know what to order. So you got 2 magnesium. So you bring it down, 2, add them together, plus O2 equals MgO. Does everybody see how we got this right here? Now we're going to practice more of this semester. We're just introducing it today. Now, I measured this before I came in here. Yours is going to be around 25 centimeters, 0.5 grams. So you're going to measure out 25 centimeters of this. And then we go to the periodic table and we find the mass. Mass in the periodic table, protons and neutrons, remember that? And you're going to divide 0.49 by 24.3. That's the mass of magnesium. Then I go to my balanced equation. For every 2 magnesiums that I use, I'm going to make 2 magnesium oxides. Then I go to the periodic table and I add magnesium, 24.3 plus oxygen, 16. 16 and 24 is around 40. And then you're going to do the math. So 0.49 times 1 times 40 gives you 0.812. So my question for you is, raise your hand, is the ash going to weigh more than the metal? No. Raise your hand. No? Okay, anybody else? Will the ash, when I burn this, weigh more than the metal? Yep. Yes, I'm showing that to you right here. If you started with 0.49 metal, the ash is going to weigh more. This kind of freaks people out. I mean, the ash is going to weigh more? How's that possible? because the oxygen sticks to it and it stays in the crucible. So the ash is predicted to weigh more. Now that's the goal. I want you to do that. See if you can see that. When you've got that, show me and I'll give you a little check mark on your paper. Our scissors here that you can cut your magnesium. The magnesium's in a strip. And you just measure it out here. You can see the centimeters is 0 to 25. Just hold that out. Is it 25? It's a little bit more. Cut a little bit of that off. Looks good. And then you put it on the balance right here. Write down the mass. About 0.51. Now you will also have to bring over your clean crucible and place it on the balance. So bring your clean crucible over. You'll need to know the mass of that because when you burn it, the ash will be in the crucible. I would recommend only bringing over the bottom part because the top part could fall off and break and that would create a problem. So I only measure the bottom. The crucible looks like this. And then we're going to place it on the triangle and we're going to light it. Light the gas. Typically, we light the match and then we turn the gas on. So we have our match. Here's our gas. So move this over just a tad. And we're going to get some matches. So we will light the match. And then we turn the gas on. Went out. Often we go from the bottom up. So I'm gonna
Just do that.
see how we got it lit there.
No.
You want to try and light it?
I can't light the match. It won't light.
Keep trying. Try a different match. There you go. Oh, go ahead. Light this.
Like what?
I don't know. Oh, good job.
I did it!
Fantastic.
I did.
Now, to hold the crucible lid, you want to grab the crucible like this. Does everybody see how I'm holding it there? Like that. You want to hold with a lot of effort.
And?
Hold tight. And you place it on here like this. To remove it, I grab it tightly. And I'll place it on the ring stand because the table might cause it to cool too fast and it could break. So when you want to remove the crucible bowl, it's the same way. I grab it like this, take it to the ring stand, let it cool. Actually, we want to let it cool on the triangle first when we turn the gas off, and then we'll take it to the ring stand. So we're going to cover this, let it heat for about, I'd say, 7 minutes. Then we'll uncover it, expose it to a little oxygen. So good.
It's not done yet.
Iron. Iron.
O is oxygen, so it's oxide?
Yeah, iron 3 oxide.
Iron and 3 oxide?
So, quiz tomorrow, unless there's a wind chill, it freezes it. Unless there's a wind chill and you get out of school.
Iron oxide?
Can you do the next one?
Yeah.
Aluminum sulfite, and this one you're just going to balance it. It's going to be Ca3 parentheses FeCN 6 parentheses 2.
Yeah, too many markers.
Yeah.
So just because it's in parentheses, it doesn't.
You have to do the double parenthesis. It's one of the triple difficult ones. And then would be iron, correction, calcium ferrocyanide. Calcium ferrocyanide.
Where's that?
Right there. Pace tomorrow. So up here, we've got some magnesium. Now we're going to add fire to it to make it an ion. And then we're going to react it with oxygen. Now based on the charges, we're going to form MgO. So you're going to make this MgO powder today. We call it an ash, not a powder. Ash, it's a powder. Now over here, this is the balanced equation for it. Now we have our metal. This is magnesium reacting it with oxygen. How much oxygen is in the atmosphere? You might know. You might know. Percentage? Raise your hand.
70.
Nitrogen's close to 80%. So N2 is 80%. Oxygen's around 19%. So, how much of your body is oxygen? 65. Very good. Careless. Now, when we react this, we make MgO. The problem here is you have O2 and you have one O. That's why we have to double the MgO. And we double the Mg. So you're going to want to write this down in your notes for the lab. Vance, write this down in the notes from your lab. This is the equation today we're doing. This is called a balanced equation. You probably saw this in middle school, like photosynthesis, C6H12O6, which would be sugar, made from water and carbon dioxide. Correction, it would be 6H2O plus 6CO2 yields C6H12O6 plus 6O2. That's photosynthesis. Most of you all have seen that in middle school. So this is a similar balanced equation, not the same. Now this metal weighs around 0.49 grams. This metal, as I put it on the balance, you're going to put it on there. You need to measure out 25 centimeters. That's what the instructions say. 25 centimeters. Now this information comes from the periodic table. Remember the mass? What's the mass associated with? Raise your hand if you know. Mass in the periodic table? Starts with a P. The mass on the periodic table is associated with two things. One starts with a P, one starts with an N. Protons and neutrons. This is the mass, right? 1 mole is the mass. It comes from the periodic table for magnesium. Now this right here comes from your balanced equation. This allows me to convert from magnesium to the ash. Then I go back to the periodic table and I add magnesium 24 plus oxygen 16. Now the question is, Lily, will the ash weigh more or less than the metal? What do you think? What? Come on, Lily. I'm asking Lily. Lily. Yes, it will weigh more. You can see right here, Lily, here's your data for that. Now, if you drop it on the table, it will not. It's like if you go to McDonald's and you're making hamburgers and you're dropping them on the floor, you're going to have something called percent error. And we can calculate your percent error and then determine, that we need to get rid of you. It's kind of like what's going on right now with teacher retirement. Teachers are living longer, and that's the problem. They didn't initially expect teachers to live so long. So they have to go back and change things because teachers are living longer and you have to pay more because they're living longer. So if you drop the crucible on the floor or on the table, then you will not be making more. But today in the lab, we want you to see if you can make more mass from the air. You're going to be pulling mass out of the air and sticking it to this metal in the ash. It's pretty cool.
Wow.
Yeah.
Wow.
That's a pro.
He's
That's
such a
excellent.
smart guy.
Did we turn the gas on and then set it on fire?
Yeah. Taking the lid off, then we'll cause it to ignite. As you can see. Now you're only going to leave the lid off for about a minute, and then you'll put it back on because you don't want the ash to get blown out of your crucible. The goal being the ash to weigh more. The ash should weigh more than the metal, based on the mathematical data. It's 0.8.
It's 0.8?
Yeah, because remember we were supposed to get around 0.8. So your error is going to be fairly low. I'd say it's probably going to be around maybe like 5% to 10%. What'd you come up with?
It was 5%.
6.2. What do you need? Down here at the bottom. You know what that's called? This is aluminum. And then, yeah.
Placement of the extra.
You know what this is? Sulfite. Yeah, it's sulfite. You don't have to memorize that. It'll be for you on the table.
So do you not
Sulfite.
the bi, tri, quad, cis, peg, whatever?
I'm not going to make you memorize reference tables, and that's what I've photocopied for you from the book for the quiz on Friday.
So just the element.
Yeah. Aluminum sulfite. How much oxygen is in the atmosphere, Naomi? Close. No. No. Rosebud, how much oxygen is in the atmosphere?
Oh.
A lot.
80%.
No, it's around nitrogen. Nitrogen is around 80%. Now your body is 65% oxygen. Good try, Annette. I mean Alyssa, sorry. What'd you say, Naomi? Right, it's around 20%. Okay? Now, up here, you'll notice that we're going to react oxygen with magnesium, which would be right here. Magnesium and the oxygen. We're going to make magnesium oxide. Weighs around 0.49 grams, right? And on the periodic table, you're going to find 24.3. So this mass comes from what? Two things. See if you remember. Raise your hand. 24.3 is the mass of magnesium. It's associated with two things. One starts with a P and one starts with an N. Raise your hand. Protons and neutrons. Very good, Naomi. All right, so that's the mass from the periodic table. Now, we had to balance the equation because we have magnesium up here. That's no problem. O2 is the problem. It doesn't come just O. It's diatomic. It exists together. And then you make MgO. So we have one O here and two there. That's a problem. So that's why we had to double this. There's two of these here. Does everybody see that?
Okay.
We have two of them. And here, because I have two, I have to come over here and put an Mg here. And then I draw a line and I add them together. You could put a little plus sign there if you wanted to. So I have two. Does everybody see that? This is called a coefficient. It tells you how many you have. So I have two of them. Now I have to use this information. This just isn't for fun. This is called the balanced equation. Is going to be used to allow me to convert magnesium to my ash. I'm going to burn this today and make an ash. Now, from the periodic table, you're going to get this information. So the periodic table, you go to it and you find the mass of oxygen. The mass of oxygen is 16 grams.
Yeah.
Right? One oxygen, 16 grams. So you're going to add 16 plus 24, and you get around 40. It's 40.3. The 0.3 is coming from that. We're going to be technical. Does everybody see where we got 40.3?
Yeah.
So, now the last question here. Will the ash weigh more than the metal? Raise your hand.
Yes.
Yes, the ash will. Now, when you do this today, your error is going to be calculated by determining how close you are to this. So that goes in the denominator. It's in the handout that I gave you. And then you have 0.812. Let's say you got 0.75, which is what Kaya did, and she got around 6.2% error. This is how you calculate your error. You're trying to get this. Wherever you work, they will have a theoretical. They'll say, this is what you need to do, and then we're going to see how you do it. And then they judge you, and if they don't like how well you do, then they get rid of you. So you have to keep this in mind that there's always a theoretical wherever you work. Keep that in mind. The formula right, you didn't get the name right. The name would be...
Let me do it. No, don't take.
Right up there.
What's with the 6 right there?
6 where? Oh, the 6 tells you have 6 of the CNs.
Oh, okay.
So if you look right here, this is the name for it. You probably don't have it memorized.
I don't know what that one is.
It's right here.
What is it?
ferrocyanide.
Okay.
About the names.
You can look on the sheet right here to find that.
Plus or plus, and that's the minus. You have to get them the same number.
So that makes one.
Yeah, so they have to get to.
You are giving my part.
Yeah, you're both yelling.
Yeah, you multiply AL. So AL is its own thing. You have to figure out how to get that to space.
You're like cross multiply like 2 will be right there.
Okay,
Good job, Shiner. It was helpful.
3 will be right there. And SO.
So is that going to be in
Yeah,
parentheses then?
I guess cross multiply, so 3 will be down here. SO 3. 3 here.
Yeah, but you need parentheses.
Yeah.
So you gotta have parentheses.
No.
You put a 3 there.
Outside. 3 is outside.
Yeah, you can have 2 3s because this
Yeah.
3 is already there. So erase that, and then put your 3 here.
So I'm right.
Yeah, and then put a parenthesis, and then you have what?
Another 3.
At the bottom. What's it called?
Aluminum the second.
Aluminum. Now you don't have to memorize these. There's a reference sheet that we'll give you. So you look at the SO3 and it's right here. It's called aluminum what? What's it called?
Sulfate.
Sulfide. Now after you do it a lot, you'll remember people's names when you say them a lot. But like when I don't see a student for like 6 months, and they say Mr. Steinecker, I'm like, I've forgotten just because I haven't said their name enough.
You know my name?
Okay? What is this called, Rachel?
Magnesium oxide.
Close. It's magnesium. Right. It's okay. Magnesium into an ion, you must give it some energy. That's called ionization energy. So we talked before about, dating, how do you know a girl's interested in you? She'll remember a little bit about you. Ionization energy. So we're going to flame this today. We're going to put fire to this. That's the ionization energy. To get the electron away requires a little ionization energy.
That's what I just said. There's fire on it. Melt it.
Ionization energy. Now when we do that, it's going to react with oxygen. Now you'll see it today. When you put flames on this, it'll take at least 30 seconds before it ignites. And when it ignites, that's when you start producing this ash. You're going to be making magnesium oxide today. That's the ash. But when you're firing it, you're trying to give it some ionization energy so it forms this ion, then it can react with this. Now this is the balanced equation right here we're doing today. Now if you notice, Noah, this is magnesium. How much of the atmosphere is oxygen? Raise your hand. Josh? It's about 20%. 80% is nitrogen. Okay, if it was that much, it would be kind of dangerous outside. Because oxygen is very flammable. You can't smoke in a nursing home around it because you'll catch on fire. Noah, right here. So we're going to make this today. Rachel, this is an ash. Okay? Now the problem here is you have 2 oxygens right here and you have 1 here. So we have to double this. Does everybody see how there's 2 of them here? Anybody not see there's 2? We had to double it because of the O2 and 1 oxygen. Now when we double this, we got to double the magnesium. That's called balancing equations. Sean, did you do this where you came from? So you're familiar with this? Okay. So what's this called right here? What's this 2 called? There's a name for it. It's called a coefficient. Yeah. You remember that? This is called what's this called?
Oxygen. Very low. O2.
What's the S? Just raise your hand. So what's the S? No.
Sodium.
No.
Something. It's
It's called a subscript. It's called a subscript coefficient. Everybody clear?
Now, as the neutrons interact with the oxygen in the atmosphere, we burn.
Okay, well you're adding energy, ionization energy to the magnesium. So when you take that lid off, it's going to get really bright. That's because the oxygen is attacking. Oxygen is very aggressive. Yeah, you don't want to, like you said, you don't want to look right at it because it could blind you.
It could blind us.
Give it about 2 minutes.
This has been on for like a good 2-3 minutes.
All right, take yours off and we'll see if the oxygen attacks it.
Shoot, he's got to take his off.
Now, you can see yours is getting red hot there on the edges.
Yeah, ours we had to start. So
You take it off. No, keep the fire on there. Because if once it goes down, it'll stop reacting.
No, it'd be even worse.
Yeah, it's not hot enough yet. Keep the lid on. Yours might be. Yours is getting really hot down the side. Yeah. I don't know what it is about your.
No, I'm scared because that was a little.
Yeah, you can see how it is. Yeah, this one's reacting over here. This is what you want to do, or you want to see. You can see the oxygen's reacting with it.
There's no one.
Right,
Yeah, see how it's going off?
Here we go, bro.
Now, you don't typically want to breathe that
I'll close my nose.
because, you know. Now, we're going to let. Perfect. Now, you can see that the flame is just a tad high.
Yeah. Why is
That's
it
all
going
right.
this way?
Well, I need to go the other way, sorry. I'm letting a little more oxygen to give me a cone. Nice cone.
Is this moisture around it?
The more oxygen you let in, the tighter the cone will be on the... That's actually getting good. You can see how the metal there is heating up. See how it's red hot now?
What about the
How
cap?
fast that heats up.
What about the cap? Oh, did
You
we
wanna
have to
keep
put
the
that
cap-
in there?
Yeah, you're going to want to put that in there. So what we'll do right now, we'll take this off, and we'll just drop that in there.
But it only had like, it only took like 30 seconds.
Okay. You can already see how red hot that's getting. Put your goggles on there, John.
Can we put it on top?
Yeah, so put it on top.
Oh, now it's getting light, bro.
That's good. The oxygen is what's causing that brightness.
Yeah.